Thank you very much, Rudy. Hello, everybody. My name is Joe Berkowitz. I'm the Director of Sales for StaticStop, and it is my pleasure to be presenting our ESD Flooring 101 or Intro to Electrostatic Discharge Flooring today with QSource. What we'll cover today are really the basics of ESD flooring. What is ESD, who it pertains to, the ESD flooring systems that are available. We'll talk about the general requirements, the standards and terms of ESD flooring, the various uses and applications of it, and go into the why you would choose an ESD floor and the criteria and the considerations revolving around that. So I guess the best place to start is what is electrostatic discharge? What is ESD? And really it begins with how static electricity is generated. Anytime two materials, surfaces, anything come in contact and separate, that creates electrostatic energy. The basic example that everybody has seen is walking across a floor, rubbing your feet on the floor, on a carpet, and going over and touching a doorknob, you get a shock. Anytime you pick your foot up off a floor after you've touched it, there is a certain amount of triboelectric charge that is going to be built up. And depending on the type of material that the two surfaces are that separate, really pertains to how much electrostatic discharge static electricity is created. For instance, if you have two pieces of rubber pulling apart, they're generally insulative and they're not going to create a tremendous amount of electrostatic discharge. Versus if you had a feather and Teflon, they would create a tremendous amount of electrostatic energy. So ESD, electrostatic discharge, or what we call ZAPs, they're measured in volts or kilovolts, and 1 kilovolt equals 1,000 volts. Typically in the ESD flooring world, you're going to see things measured in volts. So, again, the greatest example is touching a doorknob and getting a shock. That's generally 3,000 volts. So if you rub your feet in a carpet, you run over and touch your buddy or touch a doorknob and you see that spark, that's 3,000 volts. Most electronic equipment can be damaged with as little as 25 volts. Disrupting electronic data, transmissions, anything, again, that can be as little as 25 volts. So if you have things that are like sensitive electronic components, perhaps it's air traffic control towers, things of like that nature, electrostatic discharge can greatly adversely affect these operations, these components, these type of functions. And an interesting statistic is that about 60% of all computer problems are caused by electrostatic discharge. Now, most computers, when they're sealed, that's called a closed box, generally can withstand about 7,000 volts of electricity. But when you're talking about the components that make up that computer before it's closed up, those are the sensitive parts. And generally when there's an ESD event and they get shocked, it's latent damage. So it's not present, it's not observable sometimes, and it gets built into the systems and then they fail or they don't live out to their life expectancy. So along the way, ESD has caused some kind of condition or issue where there's an ESD event and you can damage that type of equipment. So one way we prevent this is with ESD flooring. ESD flooring is designed to remove the charge off the human body. Very different than the ESD function on top of a bench top or a tabletop. That system is designed to remove charges off of components and small pieces. So a big difference, because when we talk about things like conductive and dissipative, which we will get into, it's always dissipative on the bench top, but the floor could be conductive and dissipative. So again, we'll get into that as we move along, but that's the major difference. So if you're dealing with ESD on a bench top, it's vastly different than the flooring. And with flooring, it really, ESD flooring begins as anti-static flooring. So all ESD flooring should be anti-static. It should limit an amount of static electricity generated when walking on it. So true rated ESD flooring will generate less than 100 volts. And anti-static flooring stops there. It's not grounded. So it doesn't remove the charge off the body. It really is only reducing the amount of triboelectric charge built up when walking across it. A true ESD floor has a connected path to ground. So an ESD floor starts out as an anti-static floor because it will reduce the amount of triboelectric charge built up on it. But then it becomes a full-blown ESD floor when it has a path to ground. Then it's doing its job of removing the charge off the operator or the person walking on the floor, and takes that charge to ground. And one thing to note is that the person has to wear conductive footwear, whether it be ESD shoes, heel grounders, sole grounders. Otherwise, they're not connected to ground. So there are no ESD floors available that you don't have to use ESD floors or ESD shoes or a heel grounder or a ESD floor strap, a foot strap, because otherwise you would not be able to be connected to ground. ESD flooring is used in a variety of applications and places. Up here, you'll see that there are really four ESD materials that are used, or four materials that are used to make ESD flooring, and those are vinyl, carpet, rubber, and epoxy. And within each of these, there's different categories, but from a 10,000-foot view, we'll take a look at these four main overlying materials that are used. There's a lot of crossover for this material, and sometimes it's used in multiple applications, similar facilities, but in general, it will depend on the nature of the work that's being done in the room and also the type of traffic that's going across the floor. For instance, there are some SMT lines that will use vinyl, rubber, epoxy, or carpet. However, if you have forklifts or pallet jacks, that's not an environment where you really want to be using carpet. So there are certain materials that are best for certain environments, but again, there's a lot of crossover with it. In general, you'll predominantly see vinyl, epoxy used in electronics manufacturing, assembly. Carpet is used really in server rooms, control rooms, telecom rooms, and rubber is predominantly used in clean rooms and labs. Also, vinyl and epoxy are used in clean rooms very often as well. Rubber tends to be a better material when the floor has an opportunity to get wet, and that could be in some wash areas. Quite often you see it's in a lab where they may be working with a medical device that utilizes some wet processes because it's a combination device. It could be a timing of release of a drug that's in a stent that's attached to a device that uses sensitive electronic equipment. But in general, these are your four materials that you will see used for ESD flooring. Now, rating of ESD flooring materials, it's really, you're looking for three types of ratings. One is static propensity, and that's how much charges does the floor generate when it's walked across or things are rolled over it, things are moved through it. And this is measured again in kilovolts, kVs, or volts. And the measurement test that we use to measure static propensity is the ANSI ESD standard test method 97.2. And again, it's the walking voltage test, it's what it's called. And we'll go into an example of that in a few more slides ahead of us here. In general, according to ANSI standards, anything that is truly ESD rated on the floor will generate less than 100 volts when walking or rolling across it. The other rating that we use or measurement we're going to take a look at is the electrical resistance. And this is done with really two test methods. Resistance from point to point, so that's from a point on one floor to another point on the floor. And then also, is the floor taking does it have a path to ground? So is the charge coming off the body, going to the floor, going to the ground? Is the charge going from is the floor connected to ground properly? And is the operator connected to the floor, which is connected to ground? And that's done in two tests. That's the ANSI ESD STM S7.1, and then the ANSI ESD STM 97.1. And these are all measured in ohms, which is a measurement of resistance. And you would use what is called a megameter. There's various meters out there. Some are analog. You set your meter to the appropriate voltage, and then you push a button, very analog, simple, quick, and easy, and it runs all the way up through testers that have digital storage. They measure the relative humidity in the room. They'll measure the temperature of the room. They'll tell you the time, the date, and they have a lot of really cool technologies built into the testers themselves that will help with measurement processes, recording the data and reporting the data. So we'll talk about next about conductive versus dissipative. Why? I know I mentioned this earlier. Here we'll get into why and when you would go with conductive versus dissipative, who would and who wouldn't. And then again, we always want to keep in mind that the body voltage generation should be under 100 volts for any ESD flooring to be truly rated as an ESD flooring. The conductive and dissipative ranges run from 2.5 times 10 to the 4th up to 1.0 times 10 to the 10th. This is a measurement of ohms, and it measures from 25,000 ohms all the way up to 1 billion ohms. That range is both going to be covering both conductive and dissipative. Now, there are some talk out there about there being a sweet spot, or if you're within this range, you're going to be safe and okay, that the ANSI standard doesn't tell you exactly what you're supposed to do. Therefore, being in the sweet spot will cover you. And that's a misnomer. It's like saying that you don't need to be connected to the ESD floor via heel grounders or ESD shoes to have the floor function and work properly with the human operator. It's not true. The standards that you're going to need conductive or dissipative depending upon what the specification for the products you're working on or the applications that you're applying these to call for. So the simple way to sort of look at it is the more sensitive the equipment that you're working on, you want to go with conductive because it removes the charge from the body that much faster. Something that's very, very sensitive could get zapped very easily with an ESD event very quickly, and then you've caused an ESD event or damaged your components, versus something that's maybe a little less sensitive, more tolerant. You can bleed the charge off your body a little slower, and that would be dissipative. So rule of thumb, the more sensitive the equipment is that you're working on and working with, you want to go with conductive. The less sensitive, you want to go with dissipative. The conductive range is 2.4 times 10 to the 4th, or what we use as 10 to the 4th to 10 to the 6th. That means that there's 25,000 to 1 million ohms, and that is your conductive range. And dissipative is going to be 10.6 to 10 to the 9th. That is going to be 1 million to 1 billion ohms. Again, there is no sweet spot. It's dependent upon the application that you're using or the sensitivity of the equipment that you're working with, but that's what should dictate whether you're going to go with conductive or dissipative. Now, there is also talk about, I don't want to go with conductive because I'm afraid it's going to be too conductive, and then all of a sudden my people could get shocked and, heaven forbid, electrocuted. Well, that's just not going to happen in the everyday electronics components manufacturing or ESD world. The folks that are dealing with high voltage have to worry about that. So if you're not dealing with high voltage, there is no fear that you're going to become, your applications that you're working with are going to become so conductive that you could, heaven forbid, electrocute somebody by having conductive flooring. If you're going into that range where you're dealing with high voltage, you already know that, you'll know what your specifications are, and in general, the flooring that you're going to be working with is insulative. On the dissipative range, if something is, again, closed box, final assembly, air traffic control towers, call centers, 911 centers, things like that, where you're not so concerned about the sensitivity of the equipment. You don't want to disrupt anything or cause any inconsistencies, lags, or gaps in performance of the equipment. Generally, you're using dissipative. Now, the test methods. We had touched upon this briefly a few slides earlier. There are 3 test methods that are done to test the characterization of materials. We're testing, is the floor connected tile to tile? So is there a conductive plane? Is the floor connected to ground? So is there a path to ground? And is the operator connected to the floor, to the path to ground? And then the static propensity. How much voltage is generated when the person or the operator is walking across the floor? And these 3 tests are the S7.1, 97.1, and 97.2. So the first test is ANSI ESD S7.1, flooring materials, characterization of materials. This measures 2 things. We're looking to measure the tile's resistance, so point to point. Is there a conductive plane? Are the tiles connected? And this is accomplished through a variety of ways, and we'll talk a little bit about that. But the measurement is really done with the megometer that you can see right in front of you and 2 5-pound probes. The megometers may vary depending on whose system megometer that you're using. There's a variety that QSource offers, and you'll be able to see them on their website. We have one here that is a basic ESD megometer, and the probes are set up in 2 different places. And how it works is one probe is stationary, the other is moving, and then you would switch the other probe out once you've done your 6 movements with a single probe. Here you're measuring again, is there a tile-to-tile connection? And then the next you would take one of the probes will go to a point to ground, and then the other probe will stay on the floor, and you're going to measure, is there a path to ground from the floor to ground? The next is ANSI ESD standard test method 97.1. Again, it's flooring, materials, and footwear, resistance measurement in combination with the person, the operator. Is the body connected to the floor, which is connected to ground? And this is done where a person would have their ESD shoes or heel grounders on. They'd be standing on the floor, and they'd hold a device in their hand that's connected to the megometer. The megometer the megometer is connected to ground. The floor is connected to ground. It would show a continuous loop. The person would be connected. If the operator is not connected, it will show that there's a break in that loop, and it wouldn't pass testing. And the final test that we use to qualify an ESD floor is ANSI ESD STM 97.2, combination of voltage measurement with the human being. So this is what we call the static propensity, or the ESD cha-cha. The operator will have their ESD heel grounders or ESD shoes on. They would get on top of a part of the floor, and they would hold a probe in their hand that is connected to the meter, and the meter is connected to the ESD floor. and the person is going to start to walk on the floor. And what this is going to do is measure the amount of voltage that is built up as the individual is walking across the floor. And we call it the ESD cha-cha because there are certain foot movements and patterns that you're supposed to take and walk across the floor. And again, an ESD floor should be generating under 100 volts on the walking voltage test. So some sort of tenets for the ESD floors: that the floor must be connected to ground to ensure that charges bleed it away. Otherwise, it can't happen. Things like tile or glue down vinyl tiles or carpet tiles or painted on epoxies or rolled out epoxy systems, everything has to be connected to each other. In the carpets or glue down tiles or rolled sheet goods, the conductive plane is created with the adhesive that is put down on the floor. With the epoxies, there is an electrocoat that's usually put down underneath the top coat, and that is your conductive plane. And different adhesives work differently. Different adhesives are designed for different materials, and different epoxy systems work differently. You always want to consult with the manufacturer of said products to ensure that they're being applied properly, and at the end, you're going to get the functioning results that you need. Interlocking products are a different sort of breed. So interlocking vinyl tiles they ensure a tile-to-tile connection because as they're interlocked, that creates the conductive plane. You've got to be cautious of interlocking systems that require underlayments or adhesives to help create the conductive plane, or put down copper grid systems. Failures in those can be very tricky to pinpoint. So you can have an interlocking product that, if they're on a copper grid system and something rolls over it that's very heavy, pinches and splices the copper grid system, you have a failure here now in your floor because it's no longer, its path to ground has been broken. You don't know where that is. You've got to pull up the entire floor to find it. So we always recommend going with interlocking products that don't require any underlayments, any glues, adhesives, or copper grid systems. They really are the most reliable path to ground because as you add out your tiles, you're continuing to add out your conductive plane. And a lot of these interlocking products are immune to common subfloor problems like moisture or irregularities in the floor or high RH in the floor as well. And grounding the ESD floor is done really with two methods: a copper grounding strip that's embedded in conductive adhesive, and then it's run up the wall to either a grounding post pole or into an electrical outlet and grounded that way, or a grounding cord, which is, again, that's attached to the floor itself via a clip or maybe a screw and a T-nut system and a bolt, not a screw rather. And then that cord is then run to ground, either to a grounding rod, a pole, or an electrical outlet. So now that we've talked about the ESD floors, what their function is, what they're supposed to do, where they're used, what the testing methods are, how they're grounded, we can get back into a little bit about the materials themselves and their considerations, where they're used, what the advantages are. And this is a quick matrix that I have that, again, shows you the four main materials that are sort of the overliers of what materials are used for ESD flooring, but then also what some of the considerations are. So cost, the ESD or electrical properties, lifetime. When we talk about resilience, we're talking about how durable the products are, what they can withstand, how are they to maintain. So it's not just a matter of you pay your cost for the floor. There's ongoing maintenance that's required for the floors to get them to function properly, but also to give the desired aesthetic appearance. Installation costs, what type of chemicals can be used on top of these floors and what their resistances are. And again, that also tends towards how durable the floor is, depending on what the application is in your facility. And then sort of more ergonomic, sort of employee, people centric type of considerations: sound, light, ergonomics, and comfort. So if you look at things like vinyl carpet and epoxy here, they share some things, and yet they're very different in other aspects. So if we take a look at vinyl, the relative cost is moderate. Same for carpet. Epoxy can be low, running all the way up to high. Rubbers tend to be very high, the highest. ESD properties. So for vinyl and carpet, it's really considered lifetime, because embedded into the material themselves are carbon fibers generally, or metal alloys, and they don't wear out, they don't wear down, their properties don't dissipate. Unlike epoxies, some epoxies use a salt as their ESD additive, and what that does, what happens with that salt is over time, it can dissipate and wear out. So in general, we see epoxies that use salt, and these are solvent-based epoxy ESD systems. They wear out over about 5 to 7 years, predominantly happening in the high traffic areas. And this is a consideration because you're going to have to replace the ESD flooring in about 5 to 7 years. So low entry cost, higher long-term cost, higher replacement cost. Rubber, generally the properties are starting to wear out for ESD after about 10 years. And this is sort of because rubber, if you think about your tires on the road, they wear out over time with friction. Same thing with rubber floors. They can tend to wear out over time, especially in high traffic areas. So that rubber itself will start to get worn down. That's why we give it about a 10-year time span for ESD properties in rubber. Resilience, vinyl is extremely durable, puts up with a lot of abuse. So doesn't rubber. Epoxies are really the best as far as their resilience and resistance to damage, wear and tear. Carpet being the most sensitive to abuse. Maintenance, carpets are pretty much the easiest to clean along with epoxies. Rubber is pretty easy, kind of basic. You're using we always recommend using a floor cleaner, regardless of what the material is, that has ESD properties built into it, so that no matter what, you're enhancing the ESD properties, and you're not going to put something over it that could cause a non-ESD material to leave a residue, which would act as an insulative barrier. Vinyl, buffing and waxing to no waxing. There are vinyl tiles that have ESD polyurethane coatings, which is a no wax finish, and that helps to seal the tiles or the vinyl material, sheet goods, so that dirt and debris and dust can't get ground into it. Scuffs and marks come up much easier. And again, regularly cleaned with an ESD floor cleaner is what we recommend. Your various considerations for your installations. A lot of that depends on what the existing subfloor is. Is it going to need shot blasting, moisture barriers? Have you done moisture testing? Is the floor built in the 1950s and the asbestos could have been used in the glue that adheres the tiles down currently? Now you're talking about remediation, which is extremely costly. And you have things like epoxies, which are somewhat complicated depending on the system to install. And if they're installed wrong, you've got to tear it out and start all over again. So again, various considerations. Chemical resistance, epoxies are going to be the best. Rubbers are pretty good also. Carpet, chemicals are going to stain and eat away at it, whereas vinyls are going to be a lot better than that. Things like sound absorption, ergonomics, comfort, the employee-centric type of functions with the floor or aspects. Vinyl, nice and soft, resilient, feels good. Carpet, very soft, great underfoot. Epoxies, you're standing on a concrete floor with a sealant or a coating on it. And rubber, again, will also have great sound absorption, be very comfortable underfoot. And then one other thing we want to talk about is light reflection. So this is important because in a manufacturing environment, if you have a floor that is bright and reflective of light, it allows you to use less lighting in that facility. And hence, you're going to be lowering your carbon footprint, which is also another good thing. Light absorption, if it's by windows, then, again, much more natural light is coming into the facility. And that's something also that studies show that employees feel better about a well-lit, natural sunlit area. They feel that they're getting some form of call it a mental aspect to being outside. It makes them feel better about their work environment overall. Again, each material is going to bring different characteristics and have different qualities for your manufacturing facility. So maintaining your ESD floor. So this is ultimately important because, you've got really, a couple of things. You're concerned with aesthetics, but with an ESD flooring, function becomes primary, right? And if an ESD floor has dirt and debris that's built up upon it, what's going to happen is that sits on top of the floor, and that creates an insulative barrier between the floor, which could be connected to ground and functioning properly, and the operator, who could be wearing their ESD shoes or footwear. Now there's this microfine layer of dirt, dust, debris, residue from cleaning products that is a built-up insulative barrier. The majority of ESD floors that we see fail aren't because the flooring material itself isn't working. It is because it was either improperly installed, there's issues with it coming up with water coming up out of the subfloor and causing failures, but also because there's a layer of dirt and debris that is built up on the floor and it starts acting like an insulative barrier. So regularly cleaned floors, well-maintained floors, you can avoid this problem very easily. Some ESD floors you can clean with just regular water. Again, we always recommend cleaning with an ESD additive so that you can avoid any type of issue where a cleaning crew may leave a microfine layer of residue of non-ESD material on your floor, and that's just as bad as a dirt buildup on it. So choosing an ESD floor, there's a lot of considerations, and we'll go through them here. What I want to discuss with you really are why you would choose the floor that you're going to choose, what kind of constitutes that, what are some of the characteristics that folks are looking for beyond function, and what are some of the long-term considerations for the floor? Because once you put it in, it isn't really a set it and forget it type of thing. You need to have an ongoing maintenance and cleaning program. What are some of your operational concerns? And then, of course, paramount in the conversation, not to it, but always part of it, what is the costs? So when you're choosing an ESD floor, first thing you need to know, what are your requirements? So what is it going to be? Dissipative or conductive? And again, remember, our rule of thumb is the more sensitive the equipment that you're working on, the more so you would go with conductive. The less sensitive, the more you're going to lean towards dissipative. Static generation, we know that all ESD floors, true rated ESD floors, generate less than 100 volts when the operator is walking on the floor, or you have equipment rolling across, or chairs or carts rolling across the floor. And then we also want to understand, what is the lifespan of electrical properties? Certain materials will wear out over time and have a shorter ESD property lifetime, where you have other materials that have lifetime guarantees on their ESD properties. So again, these are the considerations for requirements. Let's look at some of the considerations for installation. Now, here's where you got to put your construction hat on and take a look at things from that engineer's perspective. What is going on in the room? What is the existing floor? Is it a brand new build? Is it a floor that's been around for 50 years? Is it a building that you're not sure what the substrate is made out of, if there is a moisture barrier or not. Can you go down over the existing floor? What's the condition of it? Is there floor preparation that's going to be involved? Do you have to remove an existing floor? Are you looking for a product that you could do yourself? Or is this something that you wanted to contract with a flooring installer or a general contractor? Are you going to have to reapply any materials to the floor, waxes, coatings, anything like that? And then another thing that's always coming up is reconfiguration of the room. More and more, we're seeing folks are looking for flexible spaces. And what that means is they want to have the ability to change up their lines at will, to change the layout of their floor at will, to perhaps even change facilities. Certain products will allow you to do that, like interlocking flooring, where it's 100% portable. You can pick it up and reconfigure it at will. Other applications like epoxies or glue down tiles or carpet disallow you to do that. But again, you may be in an area where the application calls for sanitary base codes and you need the floor to go up the walls. So now you're really only looking at sheet goods or epoxy floors. So all of these various considerations have to be considered, for lack of a better term, when looking at why you would choose the ESD flooring that you're choosing. So again, now we're talking about the ESD requirements. Now we're talking about the installation considerations and requirements and workarounds or work-throughs. Next, we're going to look at interlocking tiles and what that brings from an installation consideration. Because these are different, they don't require any underlayment, floor prep, or any type of grid systems to be built. And again, we always caution, if it's an interlocking tile and it requires those things, it's really no different than a glue down tile or something that's painted onto the floor. A real interlocking floor can go down over any existing substrate with no glues, no adhesives, no underlayments, no grid systems necessary, and can be picked up and reconfigured and moved at will. The other beauty of interlocking floors are, if you have an existing space, well, that's a terrible space to go into and shot blast a floor and create FOD, which you need to shot blast in order to properly prepare for epoxies or glue down materials. You don't need to put a moisture barrier down, so you're not going to have to test for moisture. You don't have to worry about that. And you don't have to move your equipment in and out of the room, because you could build your floor around the equipment. You don't have to put ESD flooring under the equipment, because equipment is generally always grounded, and it isn't a point where the human operators, are getting underneath the equipment and standing there and becoming detached and ungrounded. Again, the biggest thing that interlocking floors bring to the table in an ESD setting is that they are portable and can be reconfigured at will. So if you have problem floors, or you don't own the building and don't want to invest in the landlord's floor, it does behoove you to take a look and investigate interlocking floorings. And then also, if you have really a lot of construction considerations where there may be high moisture in the floor, or the floor is very damaged and would have to be repaired before you'd be able to put another floor over what's existing, interlocking floors are a great way to go. And then if you have access floors, interlocking floors are the only flooring that allow you to truly access the floor that's underneath it. That way, you're not putting something over your access floor that you've got to tear out and tear up to get back underneath. And also, repairs are a snap, no pun intended, with interlocking floors. You just pop out the tile that's damaged and put in a new one. Your physical performance characteristics, you got to take a look at what is the type of foot traffic, rolling traffic, mechanical traffic that's going on top of the floor. How tough is it? How durable? What's the resistance that it's going to have as far as various chemicals? And again, the various applications, the various materials that you use will tell you what they can withstand and what they can't. If you have a floor that gets wet, you're going to, and it's an epoxy floor that you're looking at, you're going to need to build treads into the floor. Can you do that? Will it still function properly as an ESD floor? Different materials have different criteria and different considerations. So, and the last thing you want to understand from a ergonomic human capital standpoint is comfort of that floor. Standing on a concrete floor all day long, it wears down on you over time. Standing on what folks like to call, it's called anti-fatigue, but yet it feels super comfy when you're standing on it because you sink down into it. But when you go to turn and pivot and move, that material actually grabs onto the soles of people's shoes and it causes them to exert more force on their joints when they twist and bend and turn and move. So anti-fatigue is actually not as ergonomically sound as a resilient vinyl or rubber. And then also choosing an ESD floor from an aesthetic standpoint. Everybody wants a floor everybody needs a floor that functions properly. They want a floor that looks great and does that also. So you got to, what are your considerations here? What is the environment that you're in? How important are aesthetics? Is there a particular color scheme that's trying to be designed and gone for in the room? Does it match the colors of the company? Does it signify various areas and processes? What are the light reflectances that you're looking for? Perhaps you want to, again, lower your carbon footprint, less lights, brighter colors on the floor. You may have an area that has a windowless room. You want to give it a sort of a neutral tone where it's not any hard colors. And something, if it's like an ITAR facility or you're bringing customers in and it's a showcase facility, what's going to pop and wow and look great? These are all various considerations, and the various materials have their limitations and some have none. With certain epoxies, you can get every color under the sun. With certain vinyl materials, you're going to get a palette of maybe 20. Maintenance is also something that you want to consider because, again, these are talking about long-term costs. How often are you cleaning the floor? What are you cleaning the floor with? Consider finishes that may have no wax or there's no such thing as maintenance free, especially if you're in environments where there's a lot of foot traffic, a lot of mechanical traffic coming through and going. If you're connected to shipping areas or large outside bay doors, your applications for cleaning are going to be more frequently. This is a disruption to operations as well. Consider that type of downtime. And then costs. You want to look at the total cost of ownership of the floor. What does it cost you to clean the floor once? How often are you going to clean it? And how many years do you expect to have the floor? Again, we always recommend going with an ESD floor cleaner. That way, no matter who's cleaning the floor, if they leave a residue on the floor, it will be an ESD residue. So it will help enhance the performance of the floor. Again, more operational considerations here. The biggest thing we always want to consider is downtime. Can you afford to shut down while you're installing an ESD floor? Or do you need a floor that you can build while perhaps you're in between shifts and runs? You may have only a week off a year where you shut the facility down. Can the floor be installed in this time frame? So various materials will give you those different types of considerations. For instance, an epoxy floor, you need to let it dry in between coats and then dry overall. Same with glue down vinyl tiles versus interlocking tiles, which you just install and they're ready to go as soon as you install them. And then lastly, cost. You always want to consider what is it going to cost you, not up front, but also the long-term cost of the floor. What is going to be the total cost of ownership? Something that is very expensive up front may be very inexpensive over the long-term life of the floor versus something that's very inexpensive up front could cost you a lot to maintain over the lifetime of the floor or has a shorter lifetime expectancy. So you're going to be replacing that floor again. Other considerations for cost are your installation costs, shutting down, downtime. When you lose production, that is true dollars that you're losing. And again, other things that can be factored into the cost are intangibles like worker comfort. Are people going to take less days off because their back isn't hurting because they're standing on a concrete floor all day long and they feel good about it and want to come to work? So again, I'm Joe Berkowitz. I really appreciate you taking the time for this presentation today. I want to thank everybody at QSource for allowing me to do this. And here are some of the resources that we have available on our various social media channels and our website. And my contact information is here. And I'd like to just open it up for Q&A now. Thank you.
Hey, Joe, that was terrific. Thank you so much for doing the presentation today. And we had a couple of questions. Some of the obvious one were, which floor could I purchase which would provide the least amount of downtime to my production while it's being installed?
So I appreciate that question greatly because we get it a lot, and it's a major concern for a lot of folks in an operating established facility. And we would always recommend going with and considering interlocking flooring. That is going to truly give you the least amount of downtime, allow you to perhaps install the floor yourself, depending on the system. And again, it gives you that portability factor. So you're not going to have to go in and shot blast a floor. You're not going to create FOD, which we all know is detrimental for equipment. You're not going to have to apply any moisture barriers. Again, that's added costs. And you're not going to have to wait for anything to cure or dry. And when you install an interlocking floor, as soon as you connect the floor, it's ready to go and be walked on and used. Once you ground it, that floor is fully functioning. It will give you the least amount of downtime, the most rapid installation, and it's the easiest to repair if there's any damage that's done.
Well, that's great. Are there any tax incentives, or what type of warranty would you get with this type of floor?
So there actually are. So according to the IRS section 179, if a flooring material is installed and it is easily removed and it's not permanently adhered or affixed to the facility, you are able to depreciate that in a 5-year time, depreciate it in a 5-year timetable versus the standard 29 years for most installed floors. And this is because the flooring itself is viewed more so as capital equipment than it is as a structural component. The other tax incentives are that if you go with a sustainable material like an interlocking floor, and a company that uses recycled content, has a written buyback program, that flooring material is now considered sustainable. You're able to attribute that to LEED points. And every state is different. So there may be certain tax incentives in your state that will, these types of interlocking tiles will be applicable for. And I think there was another part of the question that you would ask me. I apologize.
No, it's what's the warranty on these floors?
Oh, so 10-year commercial wear warranty is very standard across the industry. If it's something that needs to be the electrical properties are all guaranteed for life. Depending on the epoxy system, they may not be guaranteed at all, or they may be guaranteed for the first year or 3 years. In general, if a client were to need a warranty that extended beyond 10 years, we consider those in a case-by-case basis, but it's not unheard of, and it's not something that can't be done.
Well, that's great. I have one last question, and that's particular to what type of equipment would you use to measure the ESD floor tiles, and how many times would you test it during the life of the floor?
So the material that you're going to use is the equipment that you use is a megometer, and there are a number of these in the market. I know QSource has a number on their website that folks can take a look at and see what's going to be best for them, because they also range in price and cost as well. And again, depending on what works best for each individual organization and the people who are doing the testing would really kind of determine what type of megometer that they would want to go with. But then there's also the fact, do you want to have something that you can just digitally upload and it makes it easier across the board? Is it an information sharing type of thing also that you need? So, instead of, you may want to have a meter that digitally records everything, records things like the RH in the room and the temperature and the day and the time, and it's logging all of this versus doing it by hand. How often you test your floor depends on the organization. So there's no hard and fast rule. There's no standard for how often you should test it. The rule of thumb is every 3 months, so every quarter. Some facilities and some companies test weekly. Some do it every 6 months. Some do it once a year. It's really all dependent on that organization, what their sort of rules and guidelines and policies and procedures are. But in general, what we find are most companies are testing every 3 months to 6 months.
Well, that sounds great. That seems to be it for now. So I'd like to thank you, Joe, for this wonderful presentation. Joe Berkowitz, Director of Sales for StaticStop and SelectTech. So that'll be it for this first webinar for QSource. Thanks and have a wonderful day.
Thank you.
Okay,